Hi there, class. This is just Mr. Wee. I'm just going to go over the ice cream lab activity, specifically number 4 right here. Okay, it's asking me what is the new freezing point of a saltwater solution if 2 moles of salt were actually dissolved in 1 kilogram of water. Okay, so some things you want to kind of remember is that here's a picture of a little diagram. If I drop any solute, anything that can be dissolved into something that can dissolve it, which is called the solvent, which is our, in case water, our solute would be the salt, right? What it would do to the solvent is it would actually increase the boiling pressure of the solvent. So in our case, the solvent's water, right? It boils at about 100 degrees Celsius. If you drop in salt, theoretically, the boiling point would increase from 100 degrees. On the same token, if you drop a solute, you drop a lot of salt or whatever it is into water, the standard freezing point of water would be 0 degrees Celsius, and it says that the freezing point of water should decrease if you add solute. Now the question is how much, and it depends on how much solute it drops. Is how much does the temperature change? Okay, so that depends on how much solute you put in. So here's what we know. The change in temperature, let me get my pen, sorry. Here's the formula. The change in temperature is based on this, a constant of whatever solute you're using. In this case, this constant value of let's say salt in number 4 is going to be -2 degrees Celsius over little m, okay? And then I'll go over that in just a second. So it's the K of m, depending on the constant belonging to whoever. In this case, it's the solute of NaCl, right? And then you're going to multiply that to a molality. Okay, and what a molality is, a small m, that's basically how many moles of solute you put into how many kilograms of solvent. Okay, and then we're going to have to plug that in. Now, that's it. You're basically just going to find the change in the temperature, right? We want to see how much the temperature is going to change when we drop the solute in there. Okay, so we're given this value right here. K of F is already given to you. Like I said earlier, it's -2 degrees Celsius, and then since it's a weird kind of unit, I'm going to put over m. It's going to look like this, over m, right? Or like little cursive m. All right. Now the question is, what is our m? Like, what is that? I don't know what that is. Okay. So let me help you out. Remember, m is going to be moles of the solute over kilograms of solvent. I don't know if you can see that. I wrote that intentionally small. What I really want you to focus on is just moles over kg, but it's really moles of the solute, whoever you're dissolving, over how many kilograms of the solvent you have. All right. And now look here. I have 2 moles of salt that were dissolved into 1 kilogram of water. That's my solute. Right there, that's the guy that's getting dissolved. 2 moles of salt getting dissolved in, look at that, that's my solvent, 1 kilogram of water, okay? So the guy that's dissolved is 2.0, let's see if I can focus that, that's 2 moles of whoever's getting dissolved over. This is 1 kilogram, 1 kilogram. Right? Again, the guy that's getting dissolved on the top, 2 moles over 1 kilogram of whoever's doing the dissolving, which is water. Okay. All right. So let me rewrite that. That's going to be -2, and still going to be degrees Celsius over little m. And remember, moles over kg, I told you moles over kg is equal to m. Technically, moles over kg is equal to little m. So what that's going to do, and it's going to be, and also take into account that 2 is going to be divided by 1. So watch, 2 divided by 1 is still just going to be 2, right? I'm sorry, and don't forget, the K of F is negative. I forgot. Oh, yeah, I already took note of that. It's still negative, okay? All right, so anyway, 2 divided by 1 is 2, and moles over kg, since that's equal to little m, I'm just going to write little m instead. All right? And it looks pretty good because look what's going to happen. If I worry about the units, I tell you guys not to write in the units, but if you do, look what happens. Little m and little m actually cancel out. Kind of like a fraction, remember? Kind of like, let me draw like a little sample to the side. Kind of like 1 over 4 times just 4. You know in algebra, to multiply these two together, you can actually imagine 4 as being kind of over 1, and then the 4's will just cancel out. Because they had, like, if they're being multiplied, the numerator is the same as the denominator. These will cancel out. Oh, and the 1's technically cancel out, but they cancel to just 1, and the 4's will cancel out to just 1 as well, if you know what I'm talking about, okay? So same thing with the letters, since it's just 2m and the m's on the bottom here, M's kind of like on the numerator here. If I just kind of draw in the over 1, it's the same thing, right? You can just look at it as a fraction. So anyway, it looks finished, but there's one more component to this, okay? Now, if your solute is an electrolyte, in which this is, NaCl is an electrolyte, what that means is that NaCl, the solute, NaCl, since it's an electrolyte, will actually break down into smaller ionic components. What that means is when you drop it in, for this stuff to dissolve, it's actually going to break apart into two different things, Na and Cl, right? You have to take that into account, because if it's an electrolyte, you have to count how many parts they're being broken into. 1, 2. What that adds is this component, times N. Only if you have an electrolyte. If you have an electrolyte, you have to add this times N part to it. And that N represents how many parts your chemical is going to break down into. Mine broke down into 2 parts, NaCl, right? So I'm going to write times. Now, see how I had to times N? Now, to each part here that I wrote, I'm just going to write in how many parts that it broke into, how many ions that it break into. It broke into 2, so I'm just going to write 2, and there's actually no units for this at all. It's just 2 of these guys. There's no units attached to this guy, all right? That's kind of the nice thing about this step. All right, so I'm just going to carry down the 2 to this third step here, and I'm just going to stop it right there, all right? So right now I got, because let's see if it was like, this is completely fictional. This isn't even a right. K2Cl. If that happened, I would see that it breaks into 2 parts. One positive part, an ion part, and the other one a negative part for ions. And if you count, that'd be 3. In this case, we only had 2 parts that broke. Okay, so there we are. We have negative 2 times 2 times 2, and then the unit that's left over is going to be degrees Celsius. I'm going to have equals negative 8 degrees Celsius. That's my change in T, okay? That looks like it's finished. I can just stop there. But for you to earn full credit, especially on a test, I don't want you to just stop there, because it's asking me what is the new freezing point, not just the change in the temperature. So what I mean is this: what's the new freezing point? As in this, the change in the T we know is going to be equal to T of F minus your T of I. That means your final temperature minus your initial temperature, because that's a change in temperature, not just a temperature. That's the change between your, a temperature at the end minus the temperature that it started at. Okay, so I know that my change in temperature right here, I just calculated, is negative 8 degrees Celsius right there. My final temperature, which is technically my new freezing point, because my new freezing point is going to be the temperature at the very end, right? I don't know it yet, so I'm just going to keep it as T of F. Then you ask yourself, the new freezing point, what was the original freezing point of water? What was it? Think about it, think about it. It's not 100 degrees, that's the boiling point. It's 0 degrees Celsius. Okay, I just let the units in. You don't have to, but it really helps to do that. Okay, so now just figure out what your TFF is. It looks a little redundant, but just do this anyway, because sometimes I might give you something that's not water, and the initial freezing point might be something different. It might not always be 0 degrees. Okay, so make sure you understand why I'm doing this. Okay, so anyway, to get just TFF by itself, I'm just going to add 0, quote unquote, add 0 to both sides, because I want to get rid of 0 on this side, and whatever I do to this side of algebra, on this side of the equation for algebra, I have to do the other side. I still have to respect the rules of math, okay? So negative 8 minus plus 0 degrees is, guess what? It's just going to be negative 8 degrees Celsius, but instead of just having your TF, or your change T, you're changing your temperature, I'm actually calculating for my new temperature, which is the T of F. So here it is. That's kind of like my step 1 up here. This is like step 1. I'm going to put number 1. Step 1 is all this. Step 2 is down here to actually calculate the new freezing point. This is your final answer. Okay. So if you need to go step by step, just kind of walk through this again. Rewind. Right. Anyways, guys, that's the answer you guys should have gotten. Good luck with this, and I hope that helped in some way. If you still don't get it, I'll try explaining it in a different way, a tutorial, okay? And I will actually be here tomorrow, right? So my apologies. All right, guys, good luck tonight. Bye.